we looked at the implementation of array lists, linked lists, stacks, queues, and priority queues in chapter 24. We finished chapter 24. We're going to move to the next part of this class is designing custom data structures. So the first part of the class, we have the use of data structures from Java API. So we know all this classic data structures and how to use the data structures from the Java API. And in the second part of the class, we look at the implementation. So when we look at the implementation, we introduced the algorithm analysis, the big O notation. And the next part we're going to design and implement custom data structures. So it's going to be your own data structures. That's in chapter 25 and 26. And then actually in 27, and we're going to look at the implementation of the data structure for the set and maps. And then the last two chapters on the advanced data structures, we look at the graphs. So here in chapter 24, the programming projects. So let me give you some hint on this programming project. All right, so this first one here, we're going to implement set operations in my list. And so here we're going to use this template. So I gave you the hint on this and one of these methods already, but I'm going to give you one more today. So let's look at this. This is the template, and you need to review the code and understand the code. So we're going to go down to the methods here we need to implement. So this is the interface here, the interface and my list. So you're going to write your code. So we're going to copy this interface, my list, from the book. So let me open another tab. All right, so this is the tab here. Here we have this my list, and my list is right here. So I'm going to get the answer here and copy everything into. Let me just use this as a work area. So this is as my work area. It's not the complete code. So I'm just going to look at this here. So this is not a complete code. So this is so I look at the last time. So let me go to this two methods here. Is two array, and there's another two array. So there's two arrays. Overloaded methods, two array. So this two array, you have this my list, So all these elements, you're going to put it into array of objects. Okay. And this here to array. So you're going to actually put it into, this is the array is specified, it's already created. You're going to put the list into this array. And also, and here, and you need to return this array. Okay. Now, see, this is, you need to change this. This is not going to return no, no, no. So this is going to return the appropriate, okay, result from invoking this method. All right, so let me use, maybe I just do this one here, the last one, to array. Okay. So, all right, I'm gonna see if I'm going to write this one here and see how we do this to array for this. Okay, we can write the code. So you see this array, when you invoke this to array, this array is already given. So this is already there. It's given already. So I'm gonna move this here. What's this here? Okay. Okay. So we're gonna eventually return, and also we're gonna return this array. This is the one we're gonna return. And so I'm gonna write the code here. Is we're gonna put things into this array. So this array is already created, and this will have the fixed size already. So assume this is going to have the appropriate size. So we're going to have, this is for this is T. So let's look at the T here. I think this T is the one we're using here for this. Okay, so that is the type is, it's going to be, so here we have, this is E. So now, hey, why this is T? So this T has to be a type, it's compatible. It has to be a super type for this E, for the elements in the list, in order for the element in the list be copied into this array. So we're gonna do this something like this. This is E for every element in the list. So this is the list. You can write this code here, and I'm gonna do array brackets. Well, I think I have to use this. Yeah, we need to have the index. So let's do this. Int I from 0, and I is less than, and so here the size of the list. So the the size here, I think the size is inherited from the collection. So we're gonna have a size. So we have this collection right here, collection interface. So there's a size there. So this is going to be the size. So it is like you put this dot size, you can emit this I++. So that's everything in this my list. So you're gonna copy this. This is going to be get I into this. But we have to do a casting. So because the type is T, so we're going to do a casting for this. All right, so please note that this can be omitted, and also if you could have this, so but it's not necessary. You don't need to have this right here. So it's this list dot get I. All right, so that you're going to return array. So this, you can write the code like this. Okay. All right, do you have a question on this? Have you looked at this? Yeah. Questions? Joshua, you have questions? All right, let's look at the next one now. So the next, we're going to, all right, so this is the one here. We're going to use double linked list to implement the data structure of linked list. In the book, we have the linked list is one-way linked list. So I'm going to look at this page here. And so this is the linked list. So please look at this linked list we have here. We are using this singly linked list. So here, and see we have this is the class for the note. It's you have only one is next. So now you have the previous. So if you look at this diagram here for the implementation, so let's look at add first. So here, this is add first. So if you look at first for the single linked list, so this is the, so what do we do is, so we create one here, okay? And we're gonna link it with the existing first one and then move height to point to the new one. So that's here, and this is the code here. And we have the code, it's right here, this code. All right, we're gonna just copy the code to our program here. So let's look at this here. Okay, so this one here, and we already have this template. So we're gonna use this template. So this is the template here. And so you're gonna write the code. So here's look for write your code to write your code. So I'm going to just, you can do a search for this. So it's right here. So here's add first, add last, add, remove first. All right, so this is all. Let's do add first. So I'm just going to copy and paste add first into right here, the work area. So this is what I'm going to use here, the work area for this code here. I'm going to copy everything from this right here. So this is the one, it's for single linked list. So you create a node, and now, and here, this is the new node right here. So this new node, you just create it. and the new node is next is point to the existing first one ahead. So look at this. This is, you create this new one here, and the new node that next is going to be point to this head. So that's, you assign the head to this. See, this is how this is done here. Okay. All right, so this is the code right here. And so now, and the new head. So this node becomes, the new node becomes the new head. So the head, and the size is incremented. And look, if the tail is equal to null, means initially, if this is the empty linked list, so you have to make this tail and also point to the same node, the new node. So they point, head and tail point to the same thing. So just copy everything here. Okay, I'm gonna copy, see if I can do this copy. Let's see, maybe you're not able to do this copy. All right, I've just copied. All right, let's do this. I just copied this, but this is, I have to manually remove these numbers here. So I copied everything here. So let's do this. Let's do this. Let's do this. Remove it. And remove this number. Okay, now. Okay, this is at first. Okay, and this one here at first is for singular linked list. You have only one, you have is next. So now you look at the diagram. So we're gonna have this previous. So if you can draw this, this diagram here, if you can extend it. So please note that you add previous here, add previous to each node, add previous. So previous points to the previous one. So you need to draw this on your study paper. So put this diagram on your paper. So put this diagram on your paper. And add this previous to each previous, okay? So this is going to be, you have previous points to the previous one. Previous, okay? All right, so what is the previous value for this first one? It's going to be null. It doesn't point to anything. So this one is going to be null for the first one here. And for all this, previous will point to the previous node. So this is the diagram. If you can see, I'm going to show you here. I'm going to keep this right here, open another tab. So let's open another tab. So I'm going to open another tab here. All right, so open another tab. Let's look at the variation of the linked list. All right, so this is the variation of linked lists. All right, so this is the doubly linked list. So it's like this here. All right, so you're gonna add a new one. So you're gonna create a new one. So please note that this double linked list here, this is the node. You're gonna write your code and you're gonna see this is the node. So if you look at the code here we have, and this one here, so it's in this, if you look at this is the node. This is the node here. So the node has next and also the previous. Okay, so enjoy it on paper. All right, so now I have to do something here. Let's go back here. It's we're gonna adjust this for the double linked list. So for this, we are creating this node, but this node, please note that this node now you have next and also previous. Okay, so this is still the same. The difference now you're gonna see here is you are going to have the previous, this one here, the one here, the original first one, it's going to, the previous is going to point to the new node. You're gonna assign, so this, oh, so you're going to write the code here is this. Okay. And so this, you're going to write this here. It is the, so here we have, so you can write this here is new head dot previous is this new node. But we have a problem is right here. So what happens if this head is null? So what happens if head is null? So that you're gonna, if this head is initially null, so this step is not needed. So look at this. If in this case, if you have this is the is empty. So this, if head and tail, so there's nothing here. You create a new one, so there's no existing one. So, and we need to take care of that. Case is here. If to look at this, if write this, if head is not null, and then this is what you need to do. Okay. Well, that's actually the only thing you need to do for this case. So look at this double linked list here we have. It's the one here. And so if it's not, you don't need to do any adjustment for previous. All right, if it's not null, so this here, the first one, heads dot previous is what? It is new node. Okay. All right, let's use another example here. So I'm going to give you another example is this. It's the one here. Let's go another example. I'm going to go to next one here. So this is going to be at last. Let's do a remove something here. I'm going to do a remove here. So let's do a remove. Okay, I'm going to do this one here, remove somewhere in the middle here. Remove this, not last. There's one here, remove. All right, so here, remove index. Okay, I'm gonna copy and paste this here. No, the probably the best thing is not, this is going to be a lot of delete. So let's go down here. All right, so I'm gonna go to, there's a complete source code. I'm gonna copy from the source code. So here's the source code for linked list. So here's source code for linked list. I'm gonna copy from the source code for this remove. Okay, so this is, all right, so this is the one I'm gonna copy. All right, this one here, I'm gonna copy, see if I do this, right? This one here, remove. Okay, so I'm gonna copy right here. So use this as a work area. All right, I just copy this. So now remove, okay? Index. If index is less than 0, or index is greater than or equal to the size. So, and that's not right. This is not the right index. Just let's return null here. So you can't remove anything. So this is not in the right range, the index. All right, else, if index is 0, and you're gonna remove the first. If index is the last one, you're gonna just call remove last. We already have it. So, all right, now I'm gonna remove. Okay, this is something here. Don't be confused with previous here. Look at the diagram here we have. So the diagram here we have here is this. We have this. This is called previous. It's the one. We're gonna find this one to be deleted at the index. So this is the index. So the index from 0 and I. So I is here. So before this EI, and this is the previous. The pointer points to this, and this is after this EI. It's this current dot next. So the EI is current. So the previous and current. So that is right here, the previous and current. So here we look at the code, is this is previous initially is the head. So we just go do this traverse from this. All right, this is the index. We're gonna get all the way up to the index. It's actually, you're going to go and through this, all these steps, we get the previous. All right, and then after previous is the current. Okay, is the current. So this code can also be written as, if you want to start from 0, and then this, it's going to be index -1. So that's also fine. So if you write this code, but just note that index is going to be the current one. So this is the previous. All right, the previous. Okay, so we get this, and now we do adjustment. So the adjustment is right here. You're gonna see this is, you're gonna remove this one here, right? To remove this. So to remove this, without the double linked list is a single linked list, you just connect this EI minus ones, this one, and to EI plus one. So that is here. That's the way. Okay, now with this previous, now you need to do more here. This one has the previous here, and the previous, this EI plus one's previous has to be point to this EI minus one, that which is previous right here. This is the previous. Okay, so you're gonna write the code. It's this here. It is the current dot next dot previous. It's going to be, you assign the previous to it. So here we're going to have this everything as what we have now. We just have to add one thing, is current dot next dot previous. Okay, so this is the one here. This is current dot next dot previous is here. It's going to be assign previous into it. Assign previous into it. Okay, so just study this more and do every of this. And if you have questions, and we can continue to discuss. All right. So now let's move on to introduce a new data structure. It's a classic data structure, but we don't have any classes in the Java API for it. So we're going to design and implement our own data structure for this binary search tree. So what is this binary search tree? A binary search tree is a binary tree first, and then plus it's a search tree. So it is so there's two things. It's binary, and there's a search is based on an order. So here, so this is so here I'm going to give you the example here. Now you're going to see this. It's a binary tree. You have root, and then you have two subtrees, and this is called the left subtree, and this is called the right subtree. And so this is a recursive structure. You can see it. It's a recursive structure. And so the example here, this is a binary tree. So every node has a maximum 2 branches, and left, right. So the nodes without any children, so that's called the leaf nodes. And the first one on the top is called the root. All right. Okay, here's another example. This is also a binary tree. So this F has a left child, but it's not a right child. That's fine. So this is a binary tree. All right, so what is a binary search tree? Binary search tree is this. You can see this, everything here, for every node, the left, all the left is less than this node, and all on the right is greater than this node. So this is a binary search tree. And here, this is also a binary search tree. So everything, look at 55 on the left is less than 55, on the right is greater than 55. All right, because of this, we have very nice way to do this, and for performing search, insertion, and deletion. It's on average, the tree is going to be well balanced. So the height of the tree, it's order of log n. And so the complexity, it's order of log n for search, insertion, and deletion. And so this is, it's faster than we have the list. A list, when you do a search, is order of n time, and insertion and deletion, in the worst case, it's all order of n time. But this, it's well balanced on average, so the average time is good. All right, and here's animation for the binary search tree. So let's do a search. I'm going to search for 35. So see how it works. And this is 35 is less than 50. Search left. And 35 is greater than 25. And search right. And there's a match. So 35 is in the tree. All right, so we look at this. Another one here is, so look at 32. So let's do a search. All right, so 32 is less than 50, and 32 is greater than 25, and 32 is less than 35. So 32 is not in the tree. There's nothing after this. All right, so now this is a search. So this is how you perform search. When you do insert, let's insert 32. So this is how you're going to insert it. All right. So now, and also we can do a remove, and we're going to talk about this, how to remove it later. So now, for the tree, and there's a order. So please study, and the book can see what's the definition for in order, and for pre-order and post-order. Okay. So this is it's in this section, a tree, a traversal. So look at this. So now, we're going to, we have this general idea now. So we need to implement it. And to implement it, we're going to have, like we have data structure. So we have a data structure here for the array list, linked list, all this set and the map, all this. So we're going to have something called a binary search tree. So this is the class, binary search tree. You're creating an object of binary search tree. You can add things to the binary search tree data, remove things from this binary search tree, and performing search in the binary search tree and some other operations as well. All right, so now we're going to look at the internal data structure. How do we support this? So we are going to have this linked data structure. So this is the linked data structure here for this. We're going to have all this nodes are the objects, and the data elements are put into the nodes. So each node contains one element. So here is the top is the root. This is the node, so 60, and has left and right. So each node has this element, and there's two pointers, points to the left and right. All right, so here we can define this tree node as this. This is the class for the tree node. Element and left, right. So left points to another tree node, and right is point to another tree node. And this is the constructor. When we construct it, we always have to provide the element value. So this is the class tree node. All right, so here's the example. You can create a tree with 3 nodes. So here is 60 is the root, and now root dot left is this new tree node 55, and root dot right is this tree node and 100. Okay, so we're gonna have this. Okay. All right, so how do we do a search? And you can write the code and using this algorithm. So here is how we're going to perform a search. So here is, I'm going to search this element value E. We're going to search from this, starting from the root. So this current, if current is not null, so we're going to check this E. If E is less than current dot element. So we go to left. The current is becoming left. Else becoming, if E is greater than current dot element, it goes to right. All right. If it's not less, not greater, then it has to be equal. So then this is true. You find it. The element is in the tree. So return true. True. Yeah. All right. So all this exhausted search, and you didn't find anything. So this is going to return false. All right. So please read this. The contents very interesting. It's very I think it's educational, and it's also has applications. So for this binary search tree, so we're gonna continue in the next class. All right. So now, any questions? All right. Samuel. Samuel, are you here, Samuel? Samuel Ogalai. Samuel Ogalai. Hey, Samuel, are you here? Yeah, can you stay?
Yes.
Okay, stay after the
Yes.
class. All right. All right. You feel free to leave, and so if you have questions, please stay. Samuel, please stay. Okay.
I'm not going to be able to attend this upcoming Friday class or next Monday because
Okay.
I'm on an airplane.
Okay, I'll take a note. So just to drop me email so I have a record there. Okay.
Okay, no problem.
Yeah. Yeah. Hey, questions, Prem, Gonzalo, Aaron, Gus. All right, I'm gonna stop recording.